Good morning students. In this video, we are going to see about various mechanisms in solid dielectric breakdown. Kindly watch the video. Thank you.
Everyone, welcome back to my YouTube channel. This session I'll be providing brief information about thermal breakdown. What do you mean by thermal breakdown? First, I want to give a brief idea about thermal breakdown. What is the significance of thermal breakdown in solid dielectric material? Most of the insulation failure in high voltage power apparatus is due to thermal breakdown. Okay. Then when high voltage is applied, what will happen? A small amount of conduction current that will be flowing through the material. That means whenever you are applying high voltage, okay, it creates electric field in the particular solid dielectric material. As a result, what will happen? A small amount of conduction current that will start increasing inside the solid dielectric material. So when this conduction current, because of this conduction current, what will happen? The temperature rise. The temperature rise that will be generating inside the material that will be taken place. You are applying high voltage, that results high electric field. As a result, small amount of conduction current that will be generating inside the material. Because of that conduction current, temperature will be increasing. Temperature is start increasing inside the material. This result heat generation. The heat generation will be taken place inside the material. This results the losing of dielectric property of given dielectric material. Okay. Now we have to analysis. We have to perform the analysis of thermal breakdown. How we can perform the analysis of thermal breakdown? So first of all, consider a solid dielectric material. You are supposed to consider a solid dielectric material. Consider a solid dielectric material. Solid dielectric test piece or solid dielectric material. Solid dielectric material. You are applying high voltage. Consider a solid dielectric material. See, this is a solid dielectric material. You are applying high voltage DC. Whenever you are applying high voltage DC, what will happen? Small amount of conduction current that will be generating inside the material. This conduction current will be moving from one end of the material to other end of the material. This results bulk amount of heat generation inside the dielectric material. So you can estimate the value of heat generated inside the material, that is given by WdC. But there is one expression, E square into sigma watt per centimeter cube, where sigma is known as conductivity. And E is the value of electric field. E is the magnitude of electric field. It can be calculated by using the expression E is equal to V by D, where V is the applied voltage and D is the distance that you can calculate it. So this is the amount of heat which is generating inside the solid dielectric material under the presence of high voltage DC. Consider the next case. Consider a solid dielectric material. You are applying high voltage AC. Solid dielectric material. We have solid dielectric material. Then you are applying high voltage AC. Whenever you are applying high voltage AC, what will happen? Similar case, small amount of conduction current that will be generating inside the solid dielectric material. Because of that small amount of conduction current, bulk amount of heat will be generating inside the dielectric material. That bulk amount of heat can be calculated by using the equation WAC. That is given by, there is one expression, please note down, E square into F epsilon R tan delta divided by 1.8 into 10 to the power 12 watt per centimeter cube, where E is value of electric field. E is known as value of electric field. F is the supply frequency. Okay, in terms of hertz. Supply frequency in terms of hertz. Then tan delta is loss angle. You can write tan delta. This is a loss angle. tan delta is the loss angle or dielectric loss. You can call dielectric loss. And epsilon r is the relative permittivity. Epsilon r, that is the relative permittivity. Relative permittivity. Relative permittivity of a given solid dielectric material piece. This much of amount will be generated when you are applying high voltage AC. I hope you are understanding. WDC, expression for WDC I have given. Similarly, I have provided the expression for WAC. Now, for the both cases, you have to write the expression for how much amount of heat transferred. These are the heat generated, WAC and WDC. WAC and WDC. Basically heat generation, expression for heat generation. Heat generation, I'll be writing like this, heat generation, WAC and WDC. This is the expression for heat generation inside the dielectric material. Now I need to write the expression for how much amount of heat is getting transferred from the solid dielectric piece. Alright. How much amount of heat that is getting transferred from a given dielectric material piece. That expression I will be writing. That is called WT. There is one expression for calculation of how much amount of heat is transferred. That is represented by WT. The amount of heat which is transferred, that I can write CV into dt by dt plus K into divergent of K into gradient of T. So this is the expression which you can calculate how much amount of heat that is getting generated from solid dielectric test piece, where CV is known as specific heat of the specimen. CV is known as specific heat of a specimen. Then dt by dt, that is temperature gradient. dt by dt, temperature gradient. K is the value of thermal conductivity. K is known as thermal conductivity. K is the value of thermal conductivity. That's all about that. This is the amount of heat which is transferred from the solid dielectric material. So what we have written here? Initially we have written expression for heat generated whenever you are applying DC field. Then you have calculated what is the expression for heat generated whenever you are applying high voltage AC. And third one, this is the third expression, that is WT. WT means how much amount of heat that is getting transferred from the solid dielectric material. So these are the things which you calculated. Now when the dielectric breakdown will be occurred, according to thermal breakdown, how the dielectric breakdown will be taken place, that we are supposed to explain. That means heat generated either DC field or either AC field. So definite amount of heat will be generated. If the heat generated is exceeding heat transfer, if the amount of heat generated inside the material is greater than amount of heat which is transferred to the material, then definitely what will happen? Definitely dielectric breakdown will be taken place. I hope you understood. Either WDC or WAC that is exceeded by WT, definitely dielectric breakdown will be taken place. Note the point. Suppose if WDC or WAC that is equal to WT, nothing will happen for the dielectric material. Your dielectric material is under safe zone. That means amount of heat. We can correlate with the laws of energy conservation rule. Energy Conservation Act we can correlate. Energy conservation rule, I think you studied already. Either WDC or WAC that is equal to WT, what will happen? Your material is under equilibrium condition. Nothing will happen for the material. Okay. So this is the condition for thermal breakdown. I hope you could understand what is thermal breakdown. It is one of the normal phenomenon which will be taken place all the type of high voltage insulation material or high voltage dielectric material first you are supposed to calculate WDC, that means heat generated under DC field. Later you are supposed to calculate heat generated under AC field. Thereafter, you are supposed to calculate how much amount of heat that is transferred from the solid dielectric material, that is given by the one of the expression, that is WT. Thereafter, you can explain the condition either WAC or WDC, that is greater than WT. That means generated, if the heat generated is greater than heat transferred, obviously dielectric breakdown will be taken place. And of course, I can say one more condition: if WAC or WDC that is equal to WT, your material will be under safe zone. Nothing will be happen. That means it is under equilibrium condition. Okay, these are the different theories related to different conditions related to thermal breakdown. I hope you could understand the session. Please note down all the equation very carefully. If you are having any doubts, kindly put up on the comment box. I will revert you. I will reply back to you. Thanks for watching this video. Please share with your friends and don't forget to subscribe. Thanks a lot.
So, in this video we saw about the solid dielectric breakdown methods, and in the next video we will be seeing about maintenance of oil quality. Thank you very much.